Hey tech tourists, welcome to this another video where I will be talking about this very interesting problem, longest substring without repeating characters. So the problem statement says that given a string, find the length of the longest substring without duplicate characters. That means you don't have to have duplicate characters in your substring and find the longest one. For example, here if you say A, B, C, A, if you take length 4, then is this a possible solution? No. Why? Because A is getting duplicate. So your solution can be A, B, C. Similarly, B, C, A can also be one solution. So among all the substrings, you have to find the one which has the longest, which is 3. Okay. So, the expected time complexity which the interviewer will be looking forward is order of n, right? Brute force solution would be that you calculate all the substrings, traverse them, and then try to find whether it is a valid one or not by checking whether all the characters are unique or not. So how can you optimize it? You can use a sliding window algorithm in this. So the algorithm which you can use is a sliding window. You can maintain 2 pointers, left and right. So left is the leftmost boundary, right is the rightmost boundary. So think like it as, for example, if you have a window, right? So think of it as a window, and here is your left, right? I will call this, let's say, left, sorry about that, left, and this is your right. So this is your right window. Okay, so this is your right window. So the length of this would be, let's say this is 0 index, then you have 1, you have 2, then you have 3. Okay, so how many characters are there? 4. So what would be the, what would be the length of this? It would be, I would say, hold on, it would be what? It would be right minus left plus 1. This would be the length. 3 minus 0 plus 1, right? So that is how you calculate the length. Okay, so the idea is you have to maintain the window which has all the unique characters. So how can you do this optimally, right? Because there could be, let's say, indexes in an ideal world, it can be indexes out of the left and right also. Okay, so this is called a shrinking and expansion, right? So you have to shrink the window sometimes, you have to expand the window sometimes. Okay, and the window will always be valid. So this is very exciting 2-pointer problem, and which is a sliding window problem. So here you can shrink it or you can expand the window. Expansion will happen to get the optimal answer, that is the maximum window. Shrinking will happen when, let's say, any duplicate character is coming up, then you have to remove, you have to shrink from the left side. Okay, so that is what we are going to do. I hope you got an idea of this shrinking and expansion. And for how do you do a lookup? So in order of 1, 2 data structures come to our mind. One is the HashSet and another one is HashMap. Okay, we will be using HashSet in C++. So that is pretty good in the lookup. It will give you in order of 1 time the lookup value in all the ideal cases. So let's try to code, and as I will be coding it in C++, I will also try to explain like what I'm doing, my thinking process, and how I'm coding it, right? So let's move on. So the string can be empty. So if, let's say, s.size equals to 0, that means the length of the string doesn't exist, so it would be 0. Then I will have some, let's say, max length, which I would initialize it as 1, because the string can be 1 character would at least be there. Then I have my left boundary, which I will initialize to 0. Then right also 0, and I will maintain a set, as I mentioned to you. So let's say I maintain an unordered set so that I can do a lookup. So there are characters, so obviously I will store characters, and let's say this is my window. Okay, now I will do a right less than n, which is the size of the window. N is the size of the window, that is s.size, correct? And while n is this, and what now you can do is, let's say if you don't find any character, you can remove those particular characters which are not valid. So while let's window dot find s of, let's say, right, okay, is not equals to window dot end. That means you have found a duplicate character, and it makes your window inaccurate. So you have to shift the left pointer, you have to delete it basically. So window dot erase s of left. So why I am erasing it? Because even if, let's say, we have to remove it from the window. For example, there can be a scenario, let's say you find a b c and a, and let's say there is again a, right? Or let's say there is b. Okay, so a will also become invalid. So that is why I am doing I have to remove a also from my set and b also from my set. That is the reason I am doing it. So I will do a left plus plus here. Makes sense? And max length I would ideally calculate every time when this is happening. So let's say max length is equals to max of max length in every iteration, and it would be right minus left plus 1. And obviously you have to add a window s of right also. So I will do a window dot insert s of right. The character is inserted because it is part of your window, and you have to do a right plus plus also. And at last I can return the max length, right? So Does it look good? It looks good to me. Let's try to see if there is any edge case which could be missing. So let's try to do a dry run on this particular thing. Let's say I have a window and this is our string, okay, and initially left is 0 and right is 0, right is less than n, and then I'm starting it and I'm trying to check. It is not found. I will find the max length. It would be 1 comma 0 1 comma 1 max, and insert as of right. This would insert till here. It is fine. When I'm finding a, this is the case. It will try to remove a. If a is removed, and it's good, right, and left plus plus happens. I think this looks great to me, and I think the time complexity for this solution, let me tell you this also. The time complexity is order of n, and space complexity would be order of k. So why n? Because I am traversing this array. Each character is traversed at least once, and the maximum it can be traversed is twice the length of the string. Okay, so that is why order of 2n could be the worst, but it okay. So amortized complexity would be order of n. Then I would say the space complexity is k, where k is the maximum characters that is present in the substring or in my HashSet, that is my Windows set, and it could be the maximum characters. If it is a lower string, it can contain all these letters, digits, alphabets, in even spaces. So all the ASCII values. So considering that there can be 256 characters only, which would be the maximum value of k it can be. So let's take it as it would be ideally order of 1, but we can say it is order of n or k, whatever, right? So this is a fantastic solution. Let's try to run it and compile it and see if there are any errors. All the cases are passing. That's pretty good. And the edge, there was one edge case which we have already handled. That's why we have initializers as 1. If you don't need this, then you can make it 0. Then also it will work fine. Okay, so let's submit this C++ solution and see how it goes. It goes good, and I think this is quite cool. And if you have any questions or any doubts, you can comment on our video, and like, follow and subscribe our channel. I am doing the live coding, and I'll be covering lot of articles and interesting problems. By the way, this problem is asked in many interviews, be it senior level or junior level, in top companies like Adobe and Microsoft, Google, and like all the possible companies you can think of. This problem is being asked because it carries an important concept of sliding window, that and the technique is expansion and shrinking of the window, right? So I hope you enjoyed the video and the learning process, and yeah, see you soon. And we also have a Discord community. Feel free to check out in our channel's description. Thanks for watching.